Okay, so in the last session, we talked about iterations and functions. So mainly we talked about functions, and I try to illustrate how functions are really useful, how we can write a simple same function and can be used over and over again across different kind of same objects. So one of the examples which we saw in this case was a small script for a small function that we wrote, which decides or possibly displays the message when a customer goes to the bank and try to withdraw it. So we can think about that one as the same function can be used across all the customers the bank has. And so we don't need to write a separate function for each different customer or each different individual. So that's where the functions become really powerful, that we can keep on using the same function over and over again, as long as we keep on providing the data in the desired format, because function and at the desired format, and the arguments are at the desired locations. And towards that one, we saw, so the example what we saw there was this particular case. That's where we started with. And in this case, we were having three arguments. We are providing it the function called client balance. We have current balance, deposit, and withdrawal. And based on that, we the function proceeds taking those argument data. And then we also talked about if else loop that help you decide, that help you navigate the code and gives you an option to go two different ways. And that's where we did. Based on that, we saw that if the balance is less than what is withdrawal, then A is going to follow the left path. And if the balance is less, the withdrawal is less than the balance, then it's actually, we make the transaction successful. So that's the one example we saw. These are some of the, again, we look through the examples by putting certain numbers, and it gives us an idea like how the whole flow chart works. This was again a little bit more complex version of the same thing. We added another logical test that was else if. So the first test performs a certain kind of observation on the withdrawal and the balance, and it tried to say whether it tried to check if the individual is making or is over withdrawing from the account, and if that holds true, then basically we're going to follow this path. Then following that, if that's not true, then there are two scenarios, that the individual is making complete withdrawal of all his balance or deposit in the bank, and the balance falls to zero. In that case, we want to print a message, just a cautionary or basically less an informative message. We add another else if loop there. And in that case, this particular part of the whole flow chart gets executed. If both of those are false, then this is the default path that is actually taken. This particular code is to illustrate the workflow over here. So here again, we are providing current balance, deposit, and withdrawal, but then we have if statement. And so this if statement checks for this particular condition. If new balance minus withdrawal is less than zero, that basically means over withdrawal, then the code within this curly bracket and this curly bracket gets executed. If that is not true, then we check for another thing, which is the post withdrawal is the balance zero. If that's the case, then the code starting from this curly bracket to this curly bracket gets executed, whatever is in between. And if both of them are not true, then the finally else part of the code will be get executed. So else becomes pretty much like a default setting. So if none of the above works, then the else is the one which is going to print out a message, and that's how the whole code works. This particular scenario is just again, as an example. If later on you possibly can go, I think these slides are being shared, so you have the data. So let's say if your current balance is 200, deposit is 20, and withdrawal is 1,000, which path would you take? So just to orient your visual perception or concept of the whole workflow is really, really important when you start writing the codes. initially, when you start doing for the first time, I really recommend to write down on a flow chart, because that will give you a really good sense of where the loop, where the actual statement should be operational, where the tests should be done. Now, once you become comfortable with this and becomes really start writing a little bit more code, I don't think you need a flow chart. You will be able to get on the go. You can get the concept actually where the loop should be, where actually the logical test should be performed, all those things. So basically, I'm not going to go execute this one. You can try out later on with this particular thing. The one important thing with respect to writing functions is providing the arguments. So I would like to reiterate that particular information. So we have a function called client balance, and we expect three different inputs in order to run the client balance function. One of them is the first argument is the current balance, second is deposit, and third is withdrawal. So when we provide three numbers in this particular order, the first one is always taken as the current balance, deposit as second, and the third value is corresponding to withdrawal. That's how the code will work on. If we somehow make a mess, or basically if somehow we put this parameter in a wrong, you can say, orientation, or in a wrong place, then basically the code is not going to give us an error. It's going to keep executing it, but it's not going to work exactly what we are expecting on it. So it's really important that the values are specified at their respective places. The only way around mentioning values at different location is when you actually specify these values as, instead of putting the numbers, you specify them as current balance equals to 200, withdrawal equals to 20, and deposit equals to 20, and withdrawal equals to 220. So if you literally put those words in, then you can swap them around, then there is no issue whatsoever, because then you are actually defining those variables very explicitly, telling the function, okay, what is where. And then the downstream function should work without any particular issues. Okay, so we look into those ones. Now let's look a particular case of an if-else function, and possibly this is rather than writing a little bigger loop, this is a manner in which you can write if else in a single line. And this possibly would work if you are expecting two outcomes. So let's say it can be made more complex though, but I think that to start with, let's assume that when we have a really simple scenario, when we want to test a particular conditions, and we have, based on the condition holding true or false, we are going to perform two different analysis, or basically two different kind of outputs we are going to follow. So for example, if in this one, if we have a condition to test, if condition is true, we're going to follow expression one. Expression one is like the code one, or whatever the code is there, that's we're going to follow. And if it is false, then we are going to follow expression two. That's the way to go about it. So just for an example, here I'm testing if x is divided by 2. And when you have %/%, and then 2 basically means when x is divided by 2, what is the remainder? So this basically operator on the which is written is going to give us the remainder as an output. So if a value is divided by x and the remainder is 0, we can say that the value is even. If the value is false, we could say it's an odd. So this is an if statement, which is testing whether the number is odd and even. This can be very simply could be written in a very single line. So essentially what we are, let's say the number we are starting with, the a equals to 9. We can write if else, rather than writing if or else separately. We say if else a %/%2 is equals to 0. If it is true, this is what it has to happen, and then this is false, then this is what actually going to happen. So in this case, what we are doing is it's going to print out even if it is 0, otherwise going to print out odd. You can also change that one to something else, whatever you would like. You can have other. So for example, on the right hand side, what we are printing out is yes and no. And here we are just simply testing if the value that a holds is same as the value 1. If it is true, then the first value, which is yes, otherwise no. So that's we're doing a simple binary test and using if else statement. Okay, so for example, here what we're looking at, so the typical what I showed you in the first instance was writing the code. If you're not writing in a single line, this is how we would be writing. A equals to 1. First we test if A is same as 1, the value that is held by A is same as 1. Once that value is tested, if it is true, then it's going to print yes, otherwise it's going to print no. So this is the code which written across, let's say, 3 or 4 lines. The same can be achieved by a single line written like this. So we are doing exactly the same thing. We're putting if else. The first thing is the test we are going to perform. The second thing is if the test holds true, the first value is the value which is a value or operation or whatever you put it over here is going to get executed if this test comes out as true. If it is false, then the second element will be, if it is a code, that code will be get executed. If it is, we simply here putting no, so that no will be printed out. So I'm just going to try this code. And as you can see in the whole function, it says yes, and the same can be achieved over here in a single line. This is a way you can make your code a little bit more compact rather than writing over multiple lines. But again, it's a personal preference. You possibly see that more of the codes which possibly is published and you're trying to use, people maybe end up using something similar. The idea I'm trying to convey is just like, if you see this, then you make a sense of it, actually what's going on over there. They're simply doing an if-else statement, but in a single line. When you start writing your codes, I would basically encourage to write them as elaborative as possible, so that when you visit at a later point of time, everything will make sense. That's my personal recommendation is, but you feel free to choose any one of those ones. Yes. Now, how we can use this kind of if-else statement, let's say in more other real life examples. So let's say we have a vector called chip enrichment. And what we were trying to see is, so these are different values of chip enrichment, and we want to set up some sort of, so this is enrichment of some peaks at certain locations across the genome, let's say, and we want to set up some sort of threshold, as the threshold is the mean of this all values. And now we're going to test whether how many values are above the threshold and how many values are below the threshold. So we are using if-else statement. So we're saying if else, if chip enrichment is greater than threshold, is higher than threshold, print yes, otherwise just say no. So that's how the output is going to come. That's based on that, this particular output has come. We could also do it pretty much differently. So same example, we're just going to test if else. If chip enrichment is greater than threshold, we want to print out the enrichment values. Otherwise, we set those values to 0. So let's say for some reason downstream analysis we want to do and want to convert all the chip enrichment values which are below the threshold to be 0. We only want to retain the values which are meaningful and above threshold. So a simple code like that can achieve that. Simply saying if else chip enrichment is greater than threshold, and then if it is true, it's going to print the chip enrichment, otherwise going to print 0 instead of it. This is another way of doing something different. And basically here what we are labeling each enrichment point as whether it's a background or it's an enrichment. So let's say if the enrichment at any location is above the threshold, we'll say, okay, yeah, it's an enrichment, otherwise we refer it as a background. And that can be done actually labeling each of these data points like that. This is a little bit of more of calculation. So rather than just simply saying it like enrichment background or print this and print that, we can make it a little bit more complex. So the way we're trying to do it now, let's say the question we're trying to ask is basically how many fold the enrichment is above the threshold. So essentially enrichment divided by the threshold will give us the fold enrichment. So pretty much same thing. If else, the first statement what we are testing is the same which we have been doing so far. Now when it is true, what rather than just simply saying enrichment or the value, what we are going to print is chip enrichment divided by the threshold. That basically gives us the fold value. So now rather than just simply a static statement, we are having some code being there. So this can be really simple or could be really complex. That both are acceptable over here. And otherwise, if the chip enrichment is not above threshold, we want to print as 0. So then you can see that wherever the enrichment is above the threshold, it's basically is going to give us a value what fold enrichment it is. Okay. So let's look into the code. How does it get executed? And it will make a little bit more sense by executing those codes. So this is the chip enrichment values. This is, again, we say calculating the threshold. So let's find what's the threshold. Oh, sorry. So the threshold is 31.7. So all the values above 31.7, we're going to say is above the threshold and will be enrichment or no. So here we are executed 31. It checks whether each value is above 31.7. If it is true, it's going to print yes. Otherwise, no. So it prints no, yes, no, depending upon the value. So this value is above, this value is not. So for this one, it says no. For 34, it says yes. So that's what we are achieving. Again, in this code, we are simply printing again all the values below the threshold. We are just substituting it by value 0, and all other values we are just keeping them. So this may be sometimes kind of a filtration you would like to apply in your data frame, and we'll see an example how it can be the same code can be used in a data frame and how powerful it is if you're trying to use it. But here it's a simple one. It's a simple vector. We're just comparing whether the values are above threshold or below threshold. And based on that, we are just keeping the value or substituting values by 0. This one, as I mentioned before, this is the fold change. Now here, so you can see the values are below threshold has been converted into you can say doubles. So it's like float values or decimal values, so 0.00, 1.07. So this is pretty much the values which are above the threshold. And then what we are calculating is how many folds above the threshold. So we're dividing the enrichment values by threshold, and those values are now written instead whenever we see an enrichment rather than simply putting the values as such. We can make it even a little bit more complex. So let's say we want to do log2 fold change of this one. We want to how much values are enriched at the log2 scale. So we just simply say log2, and the threshold and enrichment scales will be now, rather than a ratio, would be printed out as a log2 scale. So this is 0.0, 1.07 on log2 scale is I think 0.095. And for example, I'm just trying to look at it. So 3.21 is, I think, 1.48. And then chip enrichment above threshold. This values look a little bit odd to me. Wait a minute, 1 second. No, those are okay. Those are okay. Sorry, I was confused. Okay, yeah, those values are corresponding log2 fold scale. So yeah, so essentially, rather than printing out the ratios, now the values those are printed out here are the log2 scale values. And again, this is the example as I discussed. You can substitute the values by simply saying whether they are above the background or they are below the background. So these kinds of substitution, if you want to do a classification sort of an test, you have to do a test and then classify each coordinate in a different categories, that can be achieved as well. This is basically a sort of an exercise. I have put it on the slide. Don't want to do it now, but I would encourage you to, so when you have time, go back and just try to write a small code using if-else loop, just to just to address this question, and that will give you some idea about how to write a particular code. Okay. Now, so far what we have seen is simple conditional tests. So any questions so far?
Yeah, I have a question.
So yeah,
this is like a previous example, client balance, and you describe function as like current balance equals 0, deposit equals 0. This is like because you wanted to assign this current balance and deposit and withdraw to 0, or it's like you should every time just start from like assign to 0.
Oh, so okay, that's where so let's so for example, in this particular case, we want to have current balance, we want to have deposit, and we want to have withdrawal, right? So the customer can, so current balance is something the bank will already have information about. Now the deposit and withdrawal basically is up to the customer, whether he's making a deposit or he's withdrawing or he's doing both. Could be both of them are possible. Now, if you don't set up the value to the 0, what happens is it will always expect 3 values to be specified there. If any time any of the values are missing, and then it's going to start. So basically that variable will not have a value down. So in a way, so let's say if I'm making a withdrawal, I'm not making any deposit. So my default deposit would be 0, right?
No, okay. So it means you should define them like,
yes. So sometimes it's good to give default values so that, okay, these if they are not specified by, let's say, somebody using this code and he doesn't specify, let's say, deposit and only they specify withdrawal, then the functions should have some value to play with. And we know that in case of this transaction, if there is no deposit, the deposit is 0. And if no withdrawal, then the withdrawal is 0, right? So these are the kind of default values I have set it up so that the function works fine. And it's a good idea to have a default values, but then you should be aware of it as well. When if you're using somewhere the same function, you should know, okay, this was the default value. So based on that, the calculation would have been made.
Okay, thank you. Yeah.
Okay, so yeah, so we look at the statements like if, else, and kind of things, and we're testing like one thing. Sometimes it may be possible that you would like to test 2 different conditions before you want to move forward. You want to, how those 2 test conditions work, based on that, you want to go down your code. So an example which we have it down is like this. So let's say we have enrichment site across the genome. So the different locations we measure the enrichment of certain transcription factor, and we see some sites have enrichment, some sites don't have enrichment. Now we also look at gene expression of profile, and we see some genes are showing change in expression and not change in expression. Now, in order to conclude that a transcription factor is working on a particular gene expression, it is required that possibly it would be, or basically we would like to set up a setting that there should be an enrichment and also there should be a change in gene expression. Then we can say, okay, this transcription factor, when it is present, is actually causing change in gene expression, right? So it's in that case, we want both statements to be true. We want that the transcription factor should have enrichment. At the same time, there should be change in gene expression. So we would like to have those statements when both should be true. There could be scenarios when you possibly you want either, so you're just looking at, okay, do we see at any location change in gene expression or change in transcription factor? We don't care if for some analysis, let's say binding of transcription factor is also really meaningful, and if gene expression is also there, that is also meaningful. Both are there, great. But even if there is change in any one of them, that also we would like to see. So that kind of condition testing we would like to do, and that's what is called compound testing. So what we are trying to do here is we're trying to test 2 conditions, and there are 2 different ways you can do it. One is called and another is called or. And is represented by and or is represented by the vertical lines generally when you're writing these codes. So our condition first, so when you're using and, in that scenario, both the conditions should be satisfied to be true. So this is our first example, when the transcription factor enrichment should be there and the change in gene expression, both should be there to say, yes, we found a gene of our interest. So in that case, we are putting and. So both should be true. If any one of them is true and other is false, that is, we don't want to actually even consider those ones. So in this scenario, a true holds only if both conditions are satisfied. So if you look at the table, this is condition 1, condition, so this is 2, again, a condition, I don't know why. So if the first is condition 1 and then condition 2, and these are the results how the loop will work. So if condition 1 is true, but the second is false, the overall effect will be false. If first is false, second is true, overall will be false. The only way you can achieve true is if both conditions are satisfied. Then you will go through the path of the true and have an expression, or what is the expression 1 will be executed. However, if both are false, it's again false. Now, in case of an OR statement, we are looking again at, this is the second example, when whether it's change in gene expression or change in change in gene expression or enrichment, both could be really useful for us. So either enrichment, that's fine, and gene expression change, that also is fine. So either condition is true, we follow the true path. The false path is only followed when both the conditions are not true. So here, if the first condition is true, second is false, the statement is still true. So yeah, change in gene expression, but no change in enrichment, but no change in expression, you're still interested into it. Second is, if the first is false, second is true, then is also true. There's no change in enrichment, but there is change in gene expression. We are still interested. That's true. So that's what we want to go to, the path of the true. There's a change in gene expression and the change in a change in enrichment as well as change in gene expression. Both are true. We're good. So that is also true. If there's no change in gene expression, there is no change in enrichment, both are false, then it goes to the false loop. So this is a compound testing, and we'll see some examples of those ones. Any questions with respect to this one? Okay. So let's say the same example I'm going to be showing here. So first is like chip enrichment values, and then we have certain threshold, same code, what we have before, or example, what we have before, and this is a transcription change in the genes corresponding to these peaks. So let's say this is an arbitrary example though. So let's say our first condition is the chip enrichment should be above the threshold, and the transcription change should be more than twofold. So we are only interested in, let's say, basically sites where the chip enrichment is above threshold and there's a twofold or more change in transcription is happening. So then the statement what we can write is if else. Now before the comma, everything comes is the testing what we are doing. Again, the if else statement, there are three values specified by comma. So the first value is this one, second is this one, and third is this one. So first is our testing statement, what we are testing. Second is what it would be if it holds true, and second if it is holds false. Okay, if the condition what we're testing it turns out to be false, then this should be executed. So we're testing if chip enrichment is greater than threshold and transcription change is greater than 2. So both statements has to be true in order to hit a yes, or in order to go through the true path or expression one path in the flow chart which we have. If even one of them is not satisfied, it's going to be hold false and no will be printed. So you can see that though here is a good chip enrichment above the threshold, our threshold is 31.7, it is 34. This is true, but this is not true. This is not above this is not above twofold. So the overall is false. So the no is printed out here. The only scenario where we see is this, where I think the gene expression is, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, so the chip enrichment is 56, which is above the threshold. And our fold change is also significant, 4.2. And that's why it printed out yes over here. Okay, this one we will come. I would think that's better if you go through the code and then do it. Right. Yeah, okay. So let's start looking at these examples. So these are same data sets, chip enrichment, set up our threshold, transcription changes. And now they are executing in the first statement. We can say chip enrichment, and we're testing and statement. So both has to be true. If it is true, yes, otherwise no. So exactly the same what was in the slide we're executing. We can change this code, whatever is in the place of yes, you would like to put something else, we can do that as well. So for example, if you want to, I don't know, you want to put log two-fold changes, you can put log two-fold changes. And whatever we would like to, we can have in the place of yes. Okay. So log two-fold of, let's say, chip enrichment. Okay, chip enrichment. And otherwise, we just want to print as 0. So then accordingly, the values will be produced over here. So you can see that using the same statement and using compound testing, and then if it holds true, you're printing one thing. If it's not, the other thing is getting executed. Okay. This code I executed earlier. So if you don't have this code, like what we're trying to, this code over here specifies that only 3 digits of any decimal value should be printed out. So if the values are bigger than that, it's going to cut it down to only 3 decimal digits. I think that's what it works on that way. So let me execute it. Okay. All right, so this is an example. What we're trying to do is now we have chip enrichment. So this is okay, right. So we're trying to make a data frame over here. So let me. This has become a little bit more complex than I thought it was. Okay, here what we're doing is we're actually creating a. So let me make it a little bit more simpler to understand so that. Okay, let me print it out first. So this is our chip enrichment value. So I just want to put it into that particular data frame rather than what is already there. Okay, right. So there's an issue somewhere. Yeah, it's extra. Okay. Good. Good. Okay. Right. Okay. So here we are creating a data frame. So we are using the function data frame. So let me stop this particular data frame being over here only, and let's see what it is, what we're trying to do here. So let's say we're making this data frame of chip enrichment and transcription changes values. So if you do that, this particular data frame will be printed out. Okay. Now, when we add this particular line over here, what we are doing is we are creating an additional column. Sorry about that. Okay. Now, when you add this particular line, what we're doing is we are adding an additional line or additional column called results. And the results, the data in the results would be based on this test which we have performed. So rather than, so far, whenever we are performing the tests were actually printed out, on the screen. Now what they're going to be, they're going to become a column in our new table. So and the test will be performed on the chip enrichment, whether it's above the threshold or transcription change is greater than twofold. If based on that, yes and no will be produced in one of the columns. So let's execute that one. And now you can see the first column is chip enrichment, transcription change, and the results has become yes and no. And this could be even more so here basically is a little bit more complex version of that one. So here the first column is chip enrichment, and it shows the chip enrichment. If the chip enrichment is how manifold the enrichment is above the threshold. And the test which we are performing is if the chip enrichment is above the threshold, then it's going to print out what fold enrichment it is, otherwise it's going to print out 0. And that same thing is basically added as one of the columns. So we have like a data frame with 3 columns, and 2 of the columns are achieved by if-else statement. So this can be really powerful in a way. So yeah, this is possibly easily reproducible. I'll just put it again, but essentially that's what we are trying to achieve over there. Now, this is an OR statement. So if any one of them is true, we would like to see the output as yes, otherwise no. So let's look at chip enrichment first. And the second one is transcription changes. Okay, those are the values. And now we are going to execute this statement. If else, if chip enrichment is above threshold or transcription change is greater than 2, if either one of them is satisfy the condition, we would like to print yes, otherwise no. Now, yes, no is just a simple options I'm providing, but these can be more complex. Like we have been doing calculating fold changes or calculating log2 fold changes. Any one of them can be used. So it can be a little bit more complex. So here, what we are doing here is we are again using the data above data frame, and then adding one more results. Now this time the one result is using a OR statement. So this way, it's gone through multiple lines. Okay. So you can see that you can have result 1, which is based on AND statement, and result 2 based on an OR statement. So what I would want you to understand here is, first of all, trying to build an idea is like additional columns in your data frame can be created by based on some test you can perform on the existing columns, so that you can then finally you can filter it out. Okay, which of the sites, okay, now once I have this data frame, let's say I want to filter out all the values which are greater than 0. So I can get rid of all the values where I don't see an enrichment. I take only the ones which have an enrichment, or based on the column 2, or based on the result 2, I pick up, if I'm picking up yes, I'm picking up all those sites where there's just either change in expression or there is an either change in the enrichment value. So that way I can then filter out those particular data from the data frame. So this is pretty much if-else loop. So the next one I want to talk about is okay, this is the same what we have been looking so far. Okay, the next what I will talk about is something called for loop. A for loop is something when you want to iterate over each elements of a given vector or a list or whatever it could be. Now here LST is a vector of 6 elements, 1, 2, 3, 4, 5, 6. And if I'm going to iterate is basically take one value at a time and do some analysis and then go to the second value and so on and so forth. The way the for loop works is, or the way we write for loops is, we say for x in LST, or LST is the vector here. So for x in LST, what it basically means is using the for loop, you want to go over each element, and every time you pick up, so the first time you pick up the first element, let's say of the whole 6 elements, I'm going to pick up the first element, which is number 1. I'm going to assign it to variable x. So x will hold value 1. And then I'm going to do some sort of analysis or some sort of calculation on those values. Here I'm just multiplying by 3 and then gives the output. So that's how it happens. So in the first instance, x value will be 1 and x multiplied by 3 is 3. Once that is completed, automatically now a for loop will shift to the next value. That time x becomes 2 and 2 is multiplied by 3, output is 6. Then once that is done, the for loop will move to the next value and then multiply by 3, 9, and so on and so forth. As soon as it's finished with first value, the next value, and next value, and keeps on going until it has exhausted all the values in your vector or in the or whatever the object you are iterating over. So this is the way you can use the for loop to go over the elements. Okay. This is a simple example. Now, this can be actually achieved in a way, if I say in a vectorized operation, you can do much more easily than this one. But just to, what I mean by that one is, so if I say x is C 1 to 3, 1 to 6, that's what we were looking at. I can simply say x multiplied by 3. I'm going to get exactly the same results with the results which I was showing you through for loop. But with the for loop, I've written that simple thing just because to understand it, but you can do lot more complex things using for loops. Okay. So yeah, if you have a vector and if you simply want to do a multiplication, you don't have to write a for loop. You just do a vectorized operation and it will be achieved really immediately. That's much more efficient way of doing it. But sometimes you may need a for loop. So for example, in this particular situation, we have values from 1 to 10. And again, this is again multiplication of 3. So it's a simple thing, but the way you will write a code is, so finally, we want all the output should be present in a vector. So let's say that vector is m. So here we're creating an empty vector. We are saying m assigned value c, open and close parenthesis, that basically an empty vector. And then we are saying for x in LST, that is x in LST has to go into the parenthesis, and then you have curly bracket, open and close. And anything between those two will be getting executed once it iterates through your function. So what it does is first x takes a value of 1. That's where it goes through. X is multiplied by 3. And then what we are trying to do is, this is a code in a way I would say we are appending or adding elements to the m vector. So the m vector, so we are saying basically to create a new vector m, or basically create a vector, not new vector, let's say create a vector which has the values of existing values of m and the new value which we had just calculated. So in the first round, the new value, the first round, the basically existing value of m is empty list. There's nothing over here, but x will be 1. So 1 multiplied by 3 is 3. So we'll have a value 3. And whatever we get out of here, assigned it to m. Now m has one element whose value is 3. So if we have done with 1, so the x will now, for loop will shift to the second element. The second element becomes x multiplied by 3 is 6. And here we're trying again saying create a vector, which is existing values of m. Now m has 3, because 1 multiplied by 3 in our previous round, that 3, 6. And it keeps on growing as you go through this iterate through your for loop, and the output will be something like this. This can be achieved just simply by vector multiplication also, but I don't want to take some really complex example to illustrate these ones. I want to make really simple ones that makes you understand that, okay, how the for loop actually works. And once the concepts are there, I think you can go over them. Okay, let me go over this one. Now this is a for loop. In this particular for loop, we are iterating over the values, but then we are trying to do some testing for each of the values as well. We're not simply just printing or multiplying. Now, this cannot be achieved basically using a simple vectorized operation. So what we are doing here is for x in LST, again, iterate over each element of x. If x is less than 4, print x to the power 2, or basically you square the value. And if x is less than 4, else that's the only else one case is x is less than 4, the other case is x is greater than 4. If the values are greater than 4, you take the square root of values. So this is some arbitrary calculation. There's no meaning to it. But what we're trying to do here is like, okay, we pick up a value, we do some conditional testing, and then based on that, when we again doing two different options based on what holds true, we do that particular operation, and then we go through the second element and then do the same thing. And if you execute this one in this way, you possibly will get values like this one. This code is basically not really right. Oh, basically, you could have achieved the same thing using if else also. So you can say if else LST less than 4, square the values. So this is not square, sorry. This is actually multiplied by values by 2, otherwise divide the values by 2. So there could be so in order to achieve the same operation, you could do n number of different ways you can get to the right, or n different ways in which you can write a code to get the same result. However, I'm taking this simple example just to illustrate how to iterate or how to use the for loops in case of R. Okay. This is actually setting up a loop for setting up multiple criteria. So here what we want to do is the 3 categories. If the values are from 1 to 3, low, 4 to 7, medium, 8 to 10 is high. And you can write a simple code to do that. And the code will be like writing a for loop for x in LST. Again, that will go iterate through the values. If x is less than 4, so that's in order to get values from less than 3. If the any value that is less than 4, we would like to print the x is low. Else, if x is greater than or equal to 4 or less than equal to 7, we want to print medium. Otherwise, whatever is left out, which is 8, 9, and 10, we want to print them as high. Now, you could see this, there is a paste function here. The paste function, I will come to just what does it actually mean. But yeah, so what I would like to basically like to convey here is like we are using the for loop, and we are using if and else statements to we are iterating over our elements, and at the same time testing different kind of conditions to do it. Okay. We can also achieve by if else statement, if else, but it's going to become a little bit more complex, but it's doable though. Okay, so let me go back and let's look at all those things. This is creating a vector 1 to 10. Again, this is creating the empty m, and then we are iterating over all the values, and m has collected all the basically the multiplication of 3. So the for loop iterate over each one of those ones, and then just store those values in m. These values got printed because we got a print statement over here. As I said, the same could have been achieved in much simpler way. So if you have an option of, let's say, whether to do a vectorized operation or you would like to write a for loop, if you can achieve the same thing by vectorized operation, go for a vectorized operation because they're more memory efficient and much more faster. A for loop is good, but should be used when, let's say, you cannot go away, when that's the only option we have to achieve what we want to achieve. There's sometimes in regular code which you are writing, they may not appear slower, but they tend to be, if you have too many for loops, generally it tends to be a little slower compared to, let's say, vectorized operations. Okay. This is the same thing which we're trying to achieve over the, basically, if the value is less than 4, we are multiplying by 2, otherwise dividing by 2, and that's exactly the same thing which you're doing here as well. This is an if-else loop, achieving exactly the same thing. So if you have multiple criteria you want to filter out, you can, this is that example, and where we are actually, what executed wrong. Here, this one, Control L, and this one, and for X in LST, we are executing this code, and it's going to go through each element through 1 to 10 and test if the value is less than 4, or the value is between 4 and value is equal to 4 or higher, or equal to 7 or lower, or it is the rest. So, and based on that is going to rank it as low, medium, and high. Okay. Now the paste command is just to combine two values when you want to print out two values together. If you, let's say, for example, let's say I have a very simple example. Let's say I want to print out, is one of the very common strings in programming languages is hello world. So what the idea here is we want to print hello and the world, but they're, let's say, two different strings. We want to print them together. If you use something like this, it's not going to work. Let's say we want to say hello, and then possibly, let's say, 4. It's going to only print the first number, it's not going to print the second number. So sometimes if you want to combine those ones together, the best way to do that, okay, wait a minute. Yeah, so that was a false one because the question exclamation mark was outside the quotes. So the only way to combine two strings together, or want to combine them, what you can use is paste. And paste, and what you say, the first value, you can say hello, and then you separate it by the second value, WO world, and then you can specify what is the separator would be. How do you want to, when you are printing them out, how do you want to separate them? So, okay, no, I'm not putting print, but okay. You want to separate them by underscore. So if you do underscore, they will be printed hello underscore world. If you want to print out by space, they will print a hello world. And let's say if you don't want to have any space between them, you just want to combine them without any whatever it is. Either that time you either can set up pay separation equals no value, no string. So separation equals to no value in between. So they will be printed like that. In that case, you have to specify separated with nothing. The easier way of doing that one is, if you don't want to separate out by anything, the paste has an option called paste 0, which basically means with no separator, and I'm going to achieve exactly the same thing. And this is what we are trying to achieve here. We are pasting this, basically combining the first value followed by the second value and then printing them out. That's the whole paste function is achieving over there. So let's look at some other loops. So the other loop, which is quite useful, is called while loop. And while loops are generally used when you don't know when a particular condition would be satisfied. Okay, so let's say if I want to say, okay, find the 100th prime number. We don't know when the 100th prime number is going to come. So we will start looking at numbers. One, okay, 1 is prime, 2 is prime, then 3 is prime, then 4 is not prime, 5, 7, 9, and then 5, 7, 11, 13. So this way we keep on going, but not every number is prime. So if I put a question like, okay, find me the 100th prime number, we don't know when we will go, which number is going to be the 100th prime number. But we want to keep on doing some sort of a test to test some sort of a test to identify the prime numbers. And when we identify the prime numbers, we keep a record, okay, which prime number it is, and we keep on doing tests until we hit the 100th one. We don't know when we're going to hit the 100th one, but we want to keep on doing that operation until we reach that particular criteria. So that's where we can use while loops. So while will be like while this thing is true, keep on doing. So basically, you'll see an example what I mean by this one. Okay, over here. So here, let's say what we're trying to figure it out is find the numbers whose square is less than 169. Okay, so which are the numbers whose square is, find all the numbers whose square is less than 169. How do we do about it? So we'll start with some numbers. So let's say we start with setting x equal to 0. First thing we will test is x square less than 169. So if you check x square is less than 169, yeah, because 0, x to the power 0 to the power 2 is 0, so it's true. So yeah, that way, so we keep record, yeah, 0 is the value. Then what we do is we go to the next number. So we started with 0, so we add 1 to it. So we increment the existing value of x by 1. So now 0 plus 1 is assigned back to x. So the value x becomes 1. We go back, square 1 to the power 2 is 1, less than 169. That's true. Print to x, which is 1. Now x value increase again by 1. So now here x was 1. The 1 plus 1, 2. We go back to the power 2 is 4. Again, less than 1. We print that one. Keep on doing. So let's say we reach the value 12. So 12 to the power 12 to the power 2 is 144. So that's correct. So it's less than 169. So it's going to print 12 and increase the value 12 again by 1. And the value becomes 13. The moment it comes back here, 13 to the power 2 is 169. Now that value is not less than 169. That is exactly the same as 169. Now at this point, the loop not breaks, but it's no longer holds true. So it starts following the false and it stops there. So now we have find that values from 0 to 12 are the numbers whose square is less than 169. We didn't know before what value we are going to stop at. So the while loop generally helps you with this. So this is the code for achieving the same. We set up the value x equals to 0. And we say while x to the power 2 is less than 169. So this is the condition that is going to be tested over here. Is less than 2, print x, change x value to x plus 1, and keep on doing this one. And it's automatically, so here the x values are appending by 1. And this change in x, we have to specify whether we want to increase the value by 1 or increase value by 200, 1,000, whatever we can say, we can increase these values, or whichever way we can end up doing it, okay? So you can simply have it. So the other way is, like, why don't you simply take value from 1 to 20? We created a vector 1 to 20 and did a for loop. We could have identified everything. Yeah, this is possible because we are looking less than 169. If I give you, let's say, if somebody puts a value like 1,279,000 or something like that, then we don't know how big our initial list has to be. So before we stop there. So then that scenarios, while loop is really useful. This is okay. This is the next statement. So okay, we'll come to that one. We'll come to that one. So let's look at the while loop. So this is exactly the same example. X equals to 1. Oh, let me clear the screen. X equals to 1. So here I'm starting rather than 0. I'm starting with 1. And I'm exactly doing the same operation what we discussed. We're checking with the x to the power 2. Oh, no. So let me do here 169. This was the original one. And we started with 0. So let me start with that one. And we are executing this function. And now if we see, why is it not? Why didn't it execute it? Wait a minute. Why is it not executing the function? Oh, that's strange. Oh, what happened? While x to the power 2 is greater than x to the power 2, Oh, it's a greater than. Okay. That's why it doesn't, because they're not greater than 2. So yeah, it immediately breaks because x to the power 2, which is 0 to the 0, is not greater than 169. It's false, so it just simply stops. This is what we are looking for. So, okay, x to the power 2 is less than 169. Print x. So it's take care of all the values, and we found that 12 is the only last value whose square is less than 169. Otherwise, at 13 it breaks and it stops. Now, there are two things which you saw here. Possibly one thing I will iterate, but here what I say, if I didn't set up this condition properly, before the condition I was using, this code was not getting executed. So this is really important, how you set up the conditional statement here. One possibility is you set it up wrong and it doesn't execute, in my case just now. The other possibility is we set this value very, very incorrectly, and we say, okay, so here I'm starting with x, okay, and I'm going to say, basically, what I'm going to check is the x square, which 1 square is greater than 0. That's true, 1 is greater than 0. So what is going to increase the value by 1 and keep on doing it. The problem with this one is this is a never-ending loop, because any value I take after 1 is square is always going to be greater than 0. This has become a never-ending loop, and if I'm not careful, I may be thinking my script is running, but my script has gone in an infinite loop, which is never going to enter. So if I execute this code, this will keep on executing forever without actually stopping, because it just keep increasing one, and then keep testing whether the value is greater than 0. Of course, the values are going to be greater than 0, and it keeps executing. And I would be submitting the script to the cluster and hoping, okay, my analysis is going on, but no, somewhere it has stuck in a loop, which is not ending. So it's generally really good idea to have a pay attention, basically, especially writing the while loops, because they're notoriously can go in infinite, you can say simulation or infinite loops, and never ends. And so it's a good idea to have something like that, to keep an eye on that one, to write them really neatly. So finally, I just want to
actually, what did you click up there to stop it from running?
So there was a red square over here. So let's say if I execute this again, okay, this is actually immediately stopped, because why did it stop? Oh no, this is a different thing. This is a different thing, actually. The code was this one. Okay, try that. So you see this one?
Yeah.
Yeah, you just simply click on that one and stop. Or you can press escape. I think escape should do the same thing. Oh no. Yeah, escape also twice. If you hit, I think it will stop it. But that's the situation where you have actually, I have not really put a thought on, okay, whether this loop is going to stop at any time. So yeah, this goes in infinite loops. And now the two other things I want to introduce here is like next and break. So next is when you don't want to do anything. Okay, so let's say you're sort of like doing some sort of a test, and if that test holds true, you just don't want to do anything. Maybe just want to skip those values which possibly satisfy those conditions. You just simply want to keep on skipping those ones and want to only keep which doesn't satisfy. So in order, the way to not to do anything is simply say next. So basically, if this value holds true, the code inside this curly brackets is next. Basically, it's not going to do anything. You just simply tell X, now pick up the second value from the list. So let's have a look at this one. So X is 1 to 10. And what I'm going to do is for value in X. So this time, each value, in a for loop, I'm picking up a value and assigning that to a variable value. So, and what I'm checking is if square root of the value is equals to 2, then just simply skip it. I'm not interested into any number whose square root is 2, which basically 4. I'm not interested in number 4. So it skip 4, and then for everything else, just print the value y. So this is what's going to happen. So it print everything except number 4. So at the number 4, it just comes here and sees the next and simply switches it, goes and picks up the next element. So the idea of the next is when you want to skip or don't want to put any code there, or you possibly, let's say if that condition is satisfied, you just simply want to move on. You just don't want to do anything. So next is something to achieve exactly the same. This is break is basically a different way. So let's say if you're iterating over a list and then you reach some value and you simply say, and that's the last thing you want to see it, you simply say break. You stop once that criteria is being met and the loop will break and stop. So this is the value from 1 to 20. And again, from our values in X, I'm again basically taking out of a square root of half. Not a square root of half. Half is the square root. So I'm square root of the value I am taking out. And when the square root of value is equals to 3, I want to print the value and break it. Otherwise, keep on going. So otherwise, I will keep going to the next value. So this loop will pick up the value. Each value it picks up, it calculates the square roots and check if the square root is equals to 3. If the square root is not, so if square root is equal to 3, this is the loop, this is the part of the code that gets executed. Else, this code gets executed. Now what this code is next. Basically, go pick up next value. So it picks up 1, test it, is the square root equals to 3? No, this is not. So it comes into the else tells go pick up the next value, which is 2. Picks up 2, takes a square root of 2, is not equal to 3. So it execute again. It cannot go through this one because this is the because the square root of 2 is not equal to 3. It's false. So it's going to try else loop. So in else loop, it enters the next else, go pick up the next value. It picks up the third number 3 and keeps doing it until it hits the value 9. So when it picks up 9, then the square root of 9 is 3. So this condition is satisfied. Immediately, this code gets executed. It prints the value and the code, and then stops the loop there. It doesn't go through the rest of the values. It has found out, let's say this is the one we found out, the first value, which is equals to 3. It stops there, and that's it. The loop is actually broken there, or yeah, it's no longer iterates over there. So let's look at it. And that's essentially it does. It only prints out that the number whose square root is 3 is 9, and it just stops there, doesn't do anything. So that's pretty much with respect to the loops and iterations and everything. So the next time when we meet, we possibly we will talk about group manipulations, which is like apply functions, and see how we can manipulate groups. So that will be really useful as well for doing data analysis.